All right, so lecture 2.7. So we're looking at combining functions, and these are the rules for combining functions, okay? So I'm just going to go ahead and reference them as we're working, and you can take the time on your own to look at them. Hopefully this is a bit of a review. Okay, so for example 1, we have two functions, f of x and g of x, okay? And they're both square root functions, so already I know if we're going to be finding their domains, I need to take into account the fact that whatever underneath the square root needs to remain positive. Okay, so we're going to find the following and then give the domain for the following. So f plus g. Whew, okay, so f plus g, well, according to my rules, f plus g is just going to be f of x plus g of x. All right, well, what is f of x? It's right there. Square root of 9 minus x squared plus the square root of x squared minus 4. And you know, looking at those two, I can't simplify what's underneath this because if I just take a look at when I factor 9 minus x squared, that's just going to be 3 minus x times 3 plus x, which is not going to be a perfect square. So I can't get rid of the radical. Same thing as if I looked at this one right here. That would just be x plus 2, x minus 2. Still can't simplify that. So that is all we can do with these two. Can't do anything more. So that is the addition of them. But I need to take a look at what their domain would be. Okay, so what is the domain of this one? Well, I know, so let's say f of x, domain. Let me just change that. Why not just write domain? So the domain of f of x, let's find this. Well, we know that the restriction is this quantity needs to be greater than or equal to 0. So 9 minus x squared needs to be greater than or equal to 0. So if I factor that, I get 3 minus x times 3 plus x needs to be greater than or equal to 0. Aha. Okay, that means I'm going to set up my little graph. Let's see if I have room for this. Yeah, okay, so my graph and my critical values are going to be -3 and 3. And then I'm just going to try my best to squish it in here. My test points, I'll pick -10, 0, and 10. And then my other points. I'm going to make my box a little less filled in as it would normally be. And then my ensign, I want it to be greater than or equal to 0. Okay, so let's see. We're allowed to let it be equal to -3 and 3. And then filling this in. 3 minus 10, that's going to be a positive, negative. So the sign is going to be, is it greater than or equal to 0? No. 0, that's going to be positive, positive. This is a yes. So we're going to fill that in. And then 10, negative, positive. So is it greater than 0? No. Okay, so that's my domain from -3 to 3. And let's find a domain of G. Well, we know the same thing. This needs to be greater than or equal to 0. So x squared minus 4 needs to be greater than or equal to 0. Factoring. That's going to be, x minus 2, x plus 2 greater than or equal to 0. With my critical values, I got my number line, so -2 to 2. Trying to give myself a bit more space this time. Test points, -10, 0, 10. Why not? I like using 10s if can. X minus 2, x plus 2, and then final sign needs to be greater than or equal to 0. Okay, go ahead. See if you can find the domain of G. Okay, let's see. So it's going to be negative, negative. Is that greater than or equal to 0? Yes. Okay, so we're going to use this. And we're allowed to let it equal to -2. So fill that in. For 0, this is going to be negative, positive. Is that greater than 0? No. 10, positive, positive. Yes. We're allowed to use 2 and forward. So our domain for G, negative infinity to negative 2, union 2 to infinity. All right, so my domain here is going to need to be the combination of these two, okay? Because I'm restricted by both of them. So we're going to need to take where they agree with each other, which is going to be, let's see, so I have negative 3 to 2, 2 to positive 3. So domain of G was this value. That was domain of G. And then domain of F is here. So where do they agree? Let me grab my highlighter. Right here. Okay, so that's my domain. So domain of, let's see, F plus G is going to equal negative 3 to 2, negative 2 including, union 2 to 3. And box that. All right, let's take a look at F minus G. So the rule, same idea, take the subtraction. It's going to equal F of x minus G of x, which is going to be square root of 9 minus x squared plus the square root of x squared minus 4, which once again I can't actually do anything to. Cannot add or subtract them. Oops, that's supposed to be a minus sign. Sorry. So that is it for the subtraction. And then we need to find the domain. I'm just going to go ahead and use the domain I had previously. Well, the same thing here. The only restrictions that I have are when this needs to be greater than or equal to 0, and this needs to be greater than or equal to 0. So it's actually going to be the exact same domain. Domain of F minus G is just going to be negative 3 to negative 2, union 2 to 3. Okay, getting a little messy here. All right, so now let's take a look at the product. So the product, you're going to take this function and multiply it to the other function. So f of x times g of x, that's going to equal square root of 9 minus x squared times the square root of x squared minus 4. So that's going to be, take a second and see if you can figure out what that's going to be. Okay, so it's going to be 9 minus x squared times x squared minus 4, the square root. All right, so let's see that we can go ahead and find the domain. Okay, so what we know is that this whole quantity under here needs to be greater than or equal to 0. Okay, so let's see. I'm going to factor it. So what I'm doing is I'm just factoring the inside quantities here. Okay, and from there we can find our critical value points and make our graph. Let me just go ahead and I'm really running out of room on this one. Now, you know what? Actually, I'm going to go ahead and put this on a sticky note. Sorry, did not plan enough room on this page. Sticky note time. All right. Okay, so our graph, our critical value point to -3, -2, 2, 3. And we're allowed to equal all of these because of that. And then I have 3 minus x, 3 plus x minus 2, x plus 2. The sign needs to be greater than or equal to 0. All right, so pick my test points. Let's do -10, -2.5, 0, 2.5, and 10. Go ahead and fill this out and see what answer you get. Okay. So plugging that in, oops, I did not leave space for the test point. I have accidentally filled up one of my other values. And of course my sticky note is pink, so the whiteout does nothing. All right, so this is going to be positive, negative, negative, negative. That in total is going to be negative, so it's not going to be greater than or equal to 0. This is going to be positive, positive, negative, negative. Total positive, yes. 0, positive, positive, negative, positive. Nope, it's not going to be greater than or equal to 0. 2.5, that's going to be positive, 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 positive. Yep, greater than or equal to 0. Last one, negative, positive. Remember, I'm plugging these values into here and seeing what the sign would be. 10 minus 2, positive. 10 plus 2, positive. So total, it's not greater than or equal to 0. So there we go, that's my domain. So domain of f of g is going to equal -3 to -2, union 2 to 3. All right. And then d of f over g. Okay, so that's going to be f of x over g of x, which is going to equal, let's see, square root of 9 minus x squared all over square root of x squared minus 4. And we can get total square root of 9 minus x squared all over x squared minus 4. And we know that that needs to be greater than or equal to 0, as well as the value here cannot equal 0. Okay, so basically, it's going to be the exact same as this, the one we just did here, but the only major difference is that the values that came from our denominator cannot be allowed to equal 0. So these two values here cannot equal 0. So it's going to be open circled this time. Okay, so the exact same thing's going to happen. You would end up taking the test values and everything. But the only major difference is that these values cannot equal 0. But the top ones can equal 0 because they're in the numerator. Okay, so that's my domain. So domain of f over g is going to equal almost the exact same one as the quotient, but remember we have to take out the values that come from the denominator because we cannot let our denominator equal 0. Okay, and then I'll go ahead and box my answers here. All right. Okay, chugging along, chugging along. Okay, so example 2. So we're given a graph this time, so two functions that are given the graphical form. One is a linear function, that's the line, the blue one. The other one is a quadratic function, which gives us the parabola. Okay, so sketching k plus g. Okay, so k plus g, Well, that means we're going to take the k of x values and add to them the g of x values. Now, to do this graphically, what we're going to do is find the matching x values and add them together to create their new y value. So, for example, let's just start from the left and go with the value of -2. So k, now the reason I picked this is because I know these dots exist. So k plus g of -2, that's going to equal k of -2 plus g of -2. Well, what is k of -2? K of -2 is -5. Plus g of -2. G of -2 is going to be 1, 2, 3, -3. So adding those, that's going to be -8. So my new value, k plus g of -2, is -8. So -2, we're going to go with -8. Ooh, 5, 6, 7, 8. It's down here. That's going to be -2, -8. All right. And then, let's see. K plus g of, and the next value we have is -1. So it's going to be k of -1 plus g of -1. K of -1 is 0. Oh, no, sorry, that's the red one. K of -1 is -3. G of -1 is 0. That's going to be -3. So we have -1, -3 right here. Let's do the next one. So the next value we have is the 0, x of 0. So k plus g of 0. So k of 0 plus g of 0. Well, k of 0 is -1. G of 0 is right there, +1. So -1 plus +1 is going to be 0. So I get the answer 0, 0. All right, next, +1. So go ahead and, so k of 1 plus g of 1, that's going to equal, so k of 1 is, this is k is the blue, it's going to be 1. Plus g of 1 is the red, that's going to be 0. So the answer is 1. So we get 1, 1. Ooh, not 1. Yeah, it is 1. Okay. And then let's see. So k of, our next value is going to be 2. K of 2 plus g of 2. K of 2 is 1, 2, 3. G of 2. Let's see. 2g is going to be -3. So we get 0. So their answer is 2, 0. 2, 0. Okay, and there we go. So we can go ahead and let me label this, sorry. 2, 0. So we go ahead and graph in our function. And this is k plus g in black. All right, so that's how you would add graphically. You go and you pick the two x values, add their quantities together, and you'll find your new value at x. And just keep going along x value by x value to find the corresponding y value. Okay, so next let's look at composition of functions. This is when you take a function and you input it into another function. Okay, so a little different. So composition of functions. So we say f of, so that little open O is f of g of x. That's going to be f, and then you input the g of x value inside as the new input. So note, we are not responsible for finding the domain of composition of functions. That was optional, but we're not going to do that. So example 3, we are given two functions, f of x equals, and there's this linear function, And then g of x equals, and we have a quadratic function. So we're asked to find f of -1. Okay, so according to the way this is inputted here, that's supposed to be f of -1. All right, so what I'm going to do is find out what f of -1 is. So f of -1, let me go ahead and color coordinate this. So f of -1 is going to be 3 times -1 minus 5. Well, that is going to end up being -3 minus 5, which is going to end up being -8. And then I need to find what f of -8 is. So that's going to equal f of, 3 times -8 minus 5. Okay, so f, and I'm inputting my new value of -8. Okay, that's going to be -24 minus 5, which is -29. Et voila. Okay. All right, so a wee bit different than the ones we've been doing before. You're inputting one function into another. So go ahead and give g of 2 a try. G of 2, excuse me. All right, so this should be g of 2. Oops, sorry, I'm going to go ahead and do the color coding again. Hopefully that helps. All right, so it's going to be g of, now what is g of 2? Well, that's going to be 2 minus my new input value of 2 squared. Okay, so then that's going to be g of 2 minus 4, which is going to be g of -2. Oops, lost the color coding there. So now I have g of -2, which means I'm going to input -2 into my function. So that'll be 2 minus something squared, which is my -2. And I get 2 minus 4, which is -2. There we go. Find the composition of functions when you're given a specific input. So notice here I was given a specific input, -1 for this one, and then 2 for this one. Okay, but let's see, page 2. This time, instead of being given, whacked the camera there. Instead of being given equations, we're given the graph. All right. So not as much algebra, going with some graphing here. So g of f of 0, well, we're told that that is g and inputting the f of 0 value. So what is f of 0? Well, I'm going to look for the x value of 0, which is here, and find f.